Good morning, everyone. Welcome to Math 1050. This is my first time doing this, so give me a little leeway here, a little slack, and hopefully each day it will improve. So today what I did is I wrote every word out, all my notes out. And I'm going to try this because this is day one. And we'll just go down my written notes slowly so that you have time to digest it, and also that perhaps you can take notes or look in your book as we move. And then hopefully my next shot would be to do it live in front of you. So here we are. We finished off at Math 1050 the last day we saw each other, last Wednesday, and what we were working at was we were looking at the formulas for circles. Recall we talked about the diameter was equal to 2 radii, and I asked you that you need to know that. You need to know that formula. The formulas we worked with where circumference of the circle was 2 pi r. That would be given to you on any test, and area equals pi r squared, that would be given. However, for your life and for those of you that are going on in math, knowing those formulas would certainly be helpful. I always use circumference equals 2 pi r. But if you are given the diameter, you can use circumference equal to pi d. Let's look. If we have a circle of radius 6 inches, then the diameter is 2 times 6, which is 12 inches. Remember, you must put measurements in. If you just have 12, then the answer is meaningless. We don't know if it's 12 feet, is it 12 minutes, what in the world are we talking about? So we do need some units of measure. For the radius of a circle and the circumference, diameter, those are all linear, so it's just plain old inches. So now let's look at the circumference of this circle. Step number 1, always write the formula down. Always write the formula. That way you can substitute in. So our book uses pi equal to 3.14, and that's what we will use. That will also be given on any test that you have. So you're going to multiply this out, and you get 37.68 inches. We did that in class on Wednesday. Now we're looking at the area of that same circle. The area is pi r squared. We're substituting in 3.14 for pi. My radius is 6 inches. I'm going to square it and get 36, multiply that out, and the area is 113.04 inches squared. Area is always a squared measure, whether it's inches squared, feet squared, centimeters squared. It's always squared. Now, we're starting the new material. If you turn in your book to page 497, look at problem number 16. What makes this one different is that instead of having an entire circle, we have what's called a semicircle, half of a circle. Well, that becomes easy because if you know the area of a whole circle, semi means half of it, and we would just take half of it. So you have a choice. Find the area of the circle and then divide by 2, or you can write 1/2 equals pi r squared, and I wrote this down. Area of a semicircle. Okay, so let's continue here. And I'm looking at a circle where I'm giving you a diameter of 15 yards. Well, notice we need radius. So a radius is half the diameter. Instead of using, well, I don't use decimals, so I just keep everything exact, 15 halves, and you can put in 15 halves the quantity squared, or you can put in 7.5 the quantity squared. Since all of you will be using your calculators, my guess is you're just going to use a decimal like that. So clearly you're going to be doing this on your calculator. I don't expect you to do that by hand, and you're going to come out with 88.3125. The measurement is squared, and you look at the directions in the book. The book said round it to the nearest tenth, so you underline the tenths position. You look to the right, we can drop the 125, and we get 88.3 yards squared. Let's look at this. We are now on page 498, and the question says, how far relates to distance. Distance refers to circumference because we're talking about a circle, and you are given the radius. Therefore, we're talking about this ball here, is that we have circumference equals 2. Always write the formula down. Substitute in 3.14 for pi, and we are given that the distance from here to the outer edge is 20 centimeters. We multiply that out, and you get 125.6 centimeters would be the distance around. So you have to look at some of the vocabulary so you know if you're finding circumference or area. This was our clue here that told us distance. Remember, do not skip word problems because that is real life. That is what we do every day, is we do word problems. So now we are done with 7.5, and we're looking now at volume and surface area. Our book gives us many figures to look at, but we're just going to be dealing with 2 of them. We're not going to be looking at all of them. The volume, what does volume mean? Volume means how much the solid holds. This is a measure of space inside a solid shape. The volume of a solid is measured in cubic units, inches cubed, centimeters cubed. So note this, we have inches cubed or centimeters cubed. Remember, area was squared, but volume is going to be cubed. The most common of all of our solids that we find the volume of is what I call the shoebox. So a shoebox is a rectangular solid. Okay. So let's consider our rectangular solid. If all sides of the solid are equal, it is a cube. So in most cases, it's not a cube. Look on page 501. The cube has all sides equal to 1 inch. What we have is volume is length times width times height. In other words, this is actually the area of the base of your rectangular solid, and then you multiply it times the height. So for the cube, 1 inch times 1 inch times 1 inch equals 1 inch cubed. We're going to write length with height as LWH. Once again, the formula would be given, but for real life, you really should try to know that because we use rectangular solids all of the time. So let's look at page 502, 1A. We are given the length is 3 meters, the width is 8, the height is 3. Substituting in, we get 72 meters times meters times meters is meters cubed. Looking at 1C. If you're given the problem in fractions, I always compute in fractions. Now 1/2 and 1/4 are exact. In other words, they do not fill up your calculator screen. But if you had 1/3, it would be 0.333 on forever. So I would compute with fractions. That's generally the rule. If it starts with fractions, end with fractions. So we're going to substitute in 6 1/4, 3 1/2, and 2, and we have to change this. 24 plus 1 is 25 over 4. 3 times 2 is 6, plus 1 is 7, and we have a 2. That gives us, I slashed my 2's, so I have 175 over 4, giving me 43 3/4. My measurement was feet, and it has to be cubed. Remember to go from an improper fraction to a mixed fraction. You're going to have to divide 4 into 175. Now, make these notes. If you're going to pretend as if we were in class, I would have you do problem 1B. I would wait for you to do that problem and then possibly do a walk and check. So you're going to have to do this on your own. So we have to do this as well as we can, the best we can, considering we have quite a few restrictions and are not face-to-face. By the way, I miss you guys. I don't like looking out here at an empty room and not seeing any faces. It's very awkward for me as well. And awkward for you. You don't see me up here explaining this. So now let's look at surface area. And we'll do the rectangular solid, which I call the shoebox. Get a shoebox out at home and look at it. And or just visualize it in your head. Is that we have a shoebox, and so we have a bottom here. This is the bottom. We have a top. We have a right-hand side. We have a left, and we have a front, and we have a back. Okay? So let's look. I chose these measurements. We have 12 inches for the front, 12 inches for this width here. This is the base. We have 9 inches here, and we have 7 inches here for the height. So surface area is what it says, area. Remember, area equals length times width. So now let's count the sides. We have a top and a bottom, which is 2. We have a right and a left, which is 2. And we have a front and a back, which is 2. That gives us a total of 6 sides. This is what I use for surface area. SA is surface area. Okay? And it will be in units squared. So we're going to find the area of these 6 sides. Okay? So let's look at the top and the bottom. Write your formula down. My length is 12 inches. My width is 9. I get 108 inches for the top. So I write down top 108, bottom 108. Then I'm going to choose the front and the back. Write your formula down. Substitute in. The front is 12 times 7. Multiply, we get 84. So I have a front equal to 84, and I have a back equal to 84 as well. Now we'll do the right and the left. And so my right, I have 9 by 7. 9 times 7 is 63. So I have a right is 63, a left is 63. I add all of these up, and my total surface area is 510 inches squared. I'm trying to get the right light here I can't see exactly how you're going to be seeing this. If it's going to be, it looks a little gray to me. I don't know how it's going to come through to you folks, but I hope it's clear. I want it to be clear. Now let's look at this. So if you think of a formula, I would never memorize a formula for this. I would just look at my box, and I would do top and bottom, right and left, front and back. I would never memorize this. But the book has this in the book. The book has this formula in the book, and you can look at it. I do not think you need it. It's just much easier to look at the rectangle and determine the areas yourself. So the less memorizing we have to do, the better it is. Okay? Hold on here. The other very popular solid that we do is what I call my soup can. So it is a cylinder. A soup can is a cylinder, and I don't know why it keeps changing light here like that. I want it to be bright, and I don't know what's controlling that here. So here we have a cylinder. Our cylinder, notice that the base of the cylinder is a circle. Okay? And then of course our soup can has a height, and we just call our height H. So to find the area of the base, which is the bottom, we know that the area of a circle is pi r squared, and volume then is always going to be the area of the base of whatever figure we're doing times the height. Okay? So our volume is pi r squared h. So once again, that will be given to you. Once again. Please look at example 4 on page 504. If when we're doing these, if you have your book right there next to you as we're doing them, I think then you can flip to the pages, you can mark, you'll have an opportunity to view this as many times as you want. So in that problem, we're given that the diameter is 20 meters. The height is 9 meters. This is our circular cylinder. So if I have a diameter, this is the diameter, it's 20. And this is my height here. My height is 9 meters. We look at the formula. We need the area of the base. Pi r squared is the base times the height. That's how I always remember all my formulas. For volume, area of the base times the height. We are given the diameter. We need r. R is 1/2 the diameter. So we divide 20 by 2, we get 10 meters. Substituting my 10 in, my pi, 3.14. I have my radius is 10 and my height is 9. So remember the order of operations. 10 squared is 100. Multiply that out. We get 2,826 meters cubed. So on the circular cylinder, I'm not going to be tricky and giving you lots of fractions or decimals or anything. I feel if you can do something reasonably basic like this, and if you have a handle on that formula, even though it's given, that is what I expect you to do. Please know that if we were in class, I would have you do page 509, number 6. So do that on your own. The even answers are not in your book, so I'm giving you the answer is given right here. Okay? And I have my inches cubed in. On the exam, if there are no units, it's minus 1/2 point if you do not give me units. Okay? We are moving along here, and now we are on 7.7. Oh, also in 7.6, the only surface area you need to do is for a rectangular solid. So my shoebox, I'm not going to hold you to doing the surface area of the cylinder. We are not doing the pyramids. We're not doing anything else. So the most important is that you understand the rectangular solid and you can find the volume of a soup can. Those are the things that are important to us. bringing us to 7.7. I can't tell you how important the Pythagorean Theorem is, not just in this class, but in many classes. For example, some of the things I teach you and that we learn in Math 1050, we don't do in Math 1100 or Math 1150. But Pythagorean Theorem never goes away. It's there. We use it in every single math class, and we use it every day in our lives. These are the perfect squares that I would expect you to know. Now, I realize that since we're not going to be doing work face to face, I have no control over if you're putting it in your calculator to get 4 squared is equal to 16. I can't control that. However, the test will have a time limit. You're not going to have time to put everything into your calculator. It's just going to take too much time. For everyday life, you really need to know up through 12. Now, my guess is that all of you know through 10 already. I would guess you know all of these perfect squares. So the two that perhaps would be new to you would be 11 squared is 121 and 12 squared is 144. Now, the part about knowing perfect squares is that we can go, forward and backward. Is that we can square it and go to 1, or if I look at this side, I can take the square root of 1, and it has to be this number over here. I take the square root of 4, and it has to be that base. Take the square root of 9, it has to be that base. The square root of 64 has to be that base, and the square root of 12 the square root of 144 has to be 12. Okay? So these are all perfect squares. These are perfect squares. But you and I know that there's a lot of numbers that are not perfect squares. If I gave you the number 50, for example, 50 is not a perfect square. So what do we do with the numbers that are not perfect squares? For the numbers that are not perfect squares, you're going to use a calculator. So on your calculator, you're going to have a function that is a square root. I'm gathering that most of you know how to use that. And so, for example, 512, problem number 2b, when we take the square root of 40, we get this number. You would look at the directions to see how you want to write it. This actually truncated, so it would be perfect. Or if it asks you to round it off to the nearest tenth, you would do 6.3. But the more digits you have, more decimal places, the more accurate our answer is going to be. So you're looking for that on your calculator. I'm sure that you have used that key and that it won't be a trouble spot for you. So these are the things we need to know going into the Pythagorean Theorem. What does the Pythagorean Theorem deal with? It deals with a right triangle. So remember, we designate the right angle with this box. The two sides that make the right angle are called legs, and the side opposite the right angle is the hypotenuse. The hypotenuse is always the longest side on the triangle. and it must be opposite the right angle. In a right triangle, it must be a right triangle. Leg squared plus leg squared equals hypotenuse squared. So you absolutely have to know this. I'm not going to give that to you on the exam. So you have to know the Pythagorean theorem. The book does not use a formula for that. He always uses these words, which is fine. But in real life, we always say a squared plus b squared equals c squared, where a and b are the legs and c is always the hypotenuse. It makes no difference if you label your triangle A and B or if you label it B and A. Absolutely no difference at all. But the C has to be opposite the right angle there. So this is one thing that we use all of the time. Let's look. This is the most popular right triangle that we have. And I gave you all three sides, and let's show how the Pythagorean theorem works. Leg squared plus leg squared equals hypotenuse squared. So one leg is 3, one leg is 4 centimeters, and the hypotenuse is 5. So we get, it actually should be centimeters squared here. And I'm showing you that indeed 9 plus 16 is 25. So looking at, this is called your 3, 4, 5 right triangle. And we just use it in math in every class. It just works out very nicely because the numbers are whole numbers. Look at page 513. I'm giving you a leg of 5 inches and a leg of 12 inches, and the question says find the hypotenuse. I think you should just use a squared plus b squared equals c squared. So I substituted in 5 squared plus 12 squared equals c squared. So we get 25, we get 144, c squared is 169, but we need, this is c to the 2, we need c to the 1. So I have to take the square root of the left, and I have to take the square root of the right. That gives me c equal to 13, and what do we have here? We have 13 inches. So we need a measurement. We need a measurement on that. Looking at 3C, same thing. We have 17 squared plus 13 squared equals c squared. Put this in your calculator. We get c squared is 458. I don't expect you to know that. And when you put it in, it's not a perfect square. So c is equal to this number here, round it off to the nearest tenth, and we get 21.4 meters. Pythagorean theorem is very important to us, and it is used regularly. Just think about all the applications of a triangle and having to find sides and heights and everything, especially in construction. Looking at page 515, you would do number 4, and I know that all of you know the square root of 81 is 9, but I don't expect you to know the square root of 2. It is 1.414. You had to put that into your calculator and get that. So you're going to do number 6, When you put that into your calculator, it will pop up. Let's look at number 20. We are given this. If we were in class, this is a class due problem, so I'm covering up the solution right now. We substitute in, you get a number, we get 225, and C equal to 15 centimeters. Now, this is very important. Note, on problem number 24, we are given the hypotenuse, but we're missing one of the legs. This is a completely different thought, but we use the same formula. So I write down a squared plus b squared equals c squared. I substitute in. I get a squared plus 25 is 169. Now, look at this. I need the a squared standing alone. So I have to subtract 25 from the left, and I subtract 25 from the right. Okay? These 25s cancel out. I get a squared equals 144. And once again, this is to the 2 power. I need it to the 1 power. So I take the square root of the left and I take the square root of the right. We get 12 meters. This is the way I do the problem. Your book also says, well, why don't, since he uses the words, he would say one leg is the square root of hypotenuse squared minus leg squared. This is on page 513. He substitutes in, and he gets the exact same answer. I refuse to memorize all these things that aren't necessary. All you need to know is this, and out comes the leg. If you choose to do it this way, that is up to you. Okay? But remember, I expect you to know the Pythagorean theorem. I will not give that on the exam. Okay? Now, the program that I'm using here at OCC does not have a pause at all. So I can never take a drink of water or do anything, just step back and, rest for a second. We don't have a pause or let you pause, but you can pause the video at home. So look at this. I would like you to do problem number 26. If we were in class, I would say, please do problem number 26. I would do a walk and check, and this is very important because this is an exercise. You want to find the hypotenuse, which should be the very basic Pythagorean problem. Here is your solution. Remember, you are doing this at home. I'm just confirming you did it correctly, and we get 12.1. We get 12.1 centimeters. Now, on the exam, I'm going to ask at least 2 Pythagorean theorem problems. One, to find the hypotenuse, which is the basic type like this one here. And I'm going to ask you to find a leg, because that we don't always know both legs of our triangle. So let's look on page 516. This is, once again, I'm waiting here for you to do that problem. You can scratch that out. I will just pause here for 1 second while you might write that down. And you draw your right triangle. You're given a leg. You're given a hypotenuse. Does it make any difference if you put your 9 here or if you put your 9 here? Whoops, I'm trying to control this. It's crazy. put it here, and it makes no difference at all. Whoops, I'm learning. Crazy to control this. Yesterday when I did my sample, I found out that I was cutting you off on the right hand side. So I'm making sure that everything that I want you to see is visible. Write your formula down. Mandatory. Mandatory. Not just in my class, in every math class. Substitute in. Compute. We want a squared to stand alone, so we have to get rid of the 81. Subtract 81. The 81s cancel out. I end up with a squared equals 175, but I need a to the 1. So I take the square root of each side, and I get 13.2. So now, remember I said, don't be skipping the word problems. So look at the problem number 40 on page 517. Very common use of the Pythagorean theorem. I see it would be helpful for me to have my book next to me, but I only have so much room on this desk here. And also the room turned off all my lights, because if there's no movement in the room, then the switch automatically goes on off. So I'm standing here in the dark, folks. Once again, all of this is new to me. So let's look. This is what's given to you in that problem. The question is, find this length. You say, okay, that's easy. That's just a basic Pythagorean theorem. I need the hypotenuse. So I write my formula down. I substitute in. 9 plus 16 is 25. I take the square root, and I get 5 feet. And someone out there might say, well, I knew it was 5 feet because you told us that 3, 4, 5 right triangle was very common. I still need computation, everybody. Yes, the 3, 4, 5 right triangle is used constantly, but I need to see all this. So remember, on the test, I always say, show all your work, and that's exactly what I mean. Now look at 42. We have this, and it's against a I believe the word it was a silo. As I said, I don't have room for my book at the moment, so I drew it this way. And so on this one, I'm not looking for the hypotenuse. I'm looking for a leg. But I write the formula down. I substitute it in. I squared everything. I want b squared to stand alone. I'm going to subtract the 1225 from each side, and I get b squared equals 1691. Of course, I don't expect you to know that square root. You're going to put that in your calculator, and you're going to come up with 41.1 feet. So the height along the silo is 41.1 feet. So I'm reiterating, word problems are important, and I have assigned several word problems. I will be attaching that to your D2L as soon as I learn how to do that, but I have it all written and scanned in so far. So I am on stress mode here, but I'm learning by the day how to do each of these things, and I hope that it is clear for you. And also, After our first week, I think all of us will be a lot more relaxed to see that, yes, we can all manage by doing a few things online. It's not our first choice, but we can manage and we get to play things more than once. In A1, remember somebody asked me at the beginning of the term what that meant. That is in the back of the book, in the appendix, and it is section A1, and it's going to deal with, we're going to do, I believe it's 1 through 4 in the appendix, and it deals with all our conversion of measurements. First, we will do the US measurements, and then second, we will do the metric measurements. Today I'm only doing US measurements, but that's plenty for us to do. So this is AP-2 is the page number. This is the page number. A1 is the section number. So it's all in the back of your book. The first thing we're looking at are what we deal with in US US length units. And these perhaps are the most common measurements that you folks use every day. You use inches, you use feet, you use yards, and we use miles, although maybe everybody doesn't know how many feet are in a mile. So I would guess all of you know 12 inches is 1 foot, and that would be what is on your ruler. Your ruler is 1 foot long. 3 feet is equal to 1 yard. I always say that's about the distance from my nose to the end of my finger there is 3 feet. And perhaps this would be new for you. 5,280 feet is equal to 1 mile. So these are units that I would expect you to know on a daily basis because we use them all the time. The more you know, the quicker it will be for you to take the exam. And you know, once again, I can't control some things because I won't be face to face when you're doing the exam, but it's going to hurt you if you don't learn them on your own. You want to know them. So that's how we measure the length of a pencil, the length of the distance or the length of the side of the room, measure our drive into school. Those are called unit lengths. Then we have US weight units. That's how we measure the weight of something. So when we're at the grocery store, we use ounces and pounds. And then if you were working with, you know, at some kind of a landscape facility, you might be measuring in tons. But for us, you want to know that 16 ounces equals 1 pound, and it takes 2,000 pounds to equal 1 ton. So looking at this now, capacity, that word means volume, or how much does it hold, and all of these are liquid measure. These are liquid measure. So let's think about what we have is that all of us drink a cup of water at a time, perhaps. 8 fluid ounces equals 1 cup. 2 cups equals a pint. So when you were in elementary school and you got that little box of chocolate, you know, chocolate milk there, and you put your straw in it, is that was 1 pint of chocolate milk. So if we pile these 2 pints on top of each other, look in your grocery store, look in the cooler section, and that is equal to 1 quart. And then if we pile the quarts next to each other, 2 in the front like this, and then 2 behind like that, my drawing here is weak because I'm losing time, is that we get a gallon of milk. So you want to think of your gallon of milk that you have at home. It's not a rectangular box, it's shaped differently. But think of it this way, is that you have 2 in the front and then you have 2 in the back, and that gives us 4 quarts. 4 quarts. So now what is left? We measured the length of our room. We weighed ourselves, or we weighed the meat that we bought. We now looked at how much milk or orange juice we bought. And then lastly, units of measure in time. So 60 seconds equals 1 minute. You know that. 60 minutes is 1 hour, 24 hours in a day, and 7 days a week. So clearly on this page here, there are some units that you say, oh yeah, I know what they are, I've used those, I've worked with those, and then maybe there are a few that are new to you. The more you know, the easier it's going to be in life when you have to convert, and also on the exam. But mostly we're working so that you have an easy life. Okay? So now this is not a new section. This just means page 2. Appendix page 2. Okay? So if you look at number 1, the problems A through M, is that I would expect you to go down. If we were in class, I would just go around the room and ask each one of you, and you would blurt out the answer to A through M. Okay? Those, there was no conversion for you to do. It was just numbers off of the list I just gave you. So now, on page, this is page 3 in the appendix, look at example 2. Now the book does not use this conversion method initially. He does use it as we go through other appendix sections, but he doesn't use it in the first one. So I suggest that we start out using it for these very easy ones, and then you will know exactly how to do it as we get to the more challenging. And look at it this way, is that we're looking at 2A. We want to convert 7 feet to 2 inches. And so all of you are saying in your head, well, that's easy. I'm just going to multiply 7 times 12, and I'm going to get the number of inches. And you are 100% correct. But let's do my way of converting so that you know it for harder ones. This is what we say. We want to go from feet to inches. So what I have to do is feet is in the numerator here. That means feet has to be in the denominator here so that the feet cancel out. Out go the feet, in come the inches. Now I have 7 times 12 is my 84, and I get inches. So I want to go from feet to inches. Always start with something that you know the answer to. So we wanted the word foot to cancel out. we got 84 inches. So some of you might be saying, oh, why are you making this so hard? Well, it's going to pay off as soon as we get to the other conversions that are more challenging. So let's look at 3.5 pounds. We want to go to ounces. This is what I do. 3.5 is 7/2 pounds. I want to get rid of the word pound, so I know there are 16 ounces in 1 pound. So the pounds cancel out. 2 goes into 16 8 times. 7 times 8 is 56 ounces. This is the abbreviation for ounces. See how easy? It's very neat, it's organized, and you say in your head, out go the pounds, in come the ounces. Let's go from quarts to gallons. Okay, so I have 20 quarts. I want to get rid of the word quart, so it has to be in the denominator. I know that there are 4 quarts in 1 gallon. The quarts cancel out. I now have 20 gallons. 20 over 4 is 5 gallons. So here we had 16 ounces per 1 pound. Here we have 4 quarts in 1 gallon. Okay? We had to get rid of that word quart, so quart had to go in the denominator. Now we're going from minutes to hours. So a lot of you say, well, I know 45 minutes is 3/4 of an hour, so we know the answer to this. Let's look at how we do it using conversions. 45 minutes, how many minutes in 1 hour? 60 minutes in 1 hour. Minutes cancel. I now have 45 over 60. I divide by 15 and I get 3/4 of an hour. Now that I did all of those, I did more than I would normally do, but I want you to, this is the initial appendix, and once I have all these conversions set up, it's going to be very easy for you as we do other conversions. Don't fight me. Just do it this way and it will be the easiest. Remember, if on the exam you just wrote down 84 here and no computation, you're not going to get credit. You must show work. You must show your work. Looking at page 3 in the appendix, we want to go from feet to inches. So 5 times 2 is 10, plus 1 is 11/2 feet. Out go the feet, in come the inches. 11 times 6 is 66 inches. Are you feeling comfortable with this? I hope so. Let's look. 64 ounces to pounds. Okay, so I need to know how many ounces are in 1 pound. I have 64 ounces. I know. How did I know to put that 16 in the denominator? Well, I needed to get rid of the word ounce, so I had to put the 16 ounces in the denominator and the 1 pound in the numerator. I have 64 over 16. I divided by, that divided out evenly, and I got 4 pounds. Okay, feeling more comfortable? I hope so. Okay, on C we want to go from yards to feet. So we know that there are 3 feet in 1 yard. Out go the yards, in come the feet. 6 times 3 is 18. A very organized way to do this. So if you can pause your video, you would want to just pause right there and just take a break, because I would like you to do a couple of these problems here. I don't have the ability at my end to pause, unfortunately. I'm dying of thirst here. So let's look. So we want to go from tons to pounds. And a lot of you have never worked with tons unless you've worked at a landscaper and he's dealing tons of dirt and tons of this and that. So we want to get rid of the word ton, so ton had to go in the denominator. So I have 1 ton in the denominator. How many pounds? There's 2,000 pounds in 1 ton. The tons cancel. 2 times 2,000 is 4,000 pounds. Minutes to hours. Okay, so some minutes, like 30 minutes, we know is a half hour. 45 minutes was 3/4 of an hour. Some things we know, but I still am looking for you to show the work. Let's look at some like 20 minutes. So we want to get rid of minutes. So minutes has to go in the denominator. There are 60 minutes in 1 hour. So the minutes cancel. I have 20 over 60, or 1/3 of an hour. What I forgot to do was time this. Okie dokie. My audio digital input here. Hold on. Hold on here. I don't know if I'm losing you or not, but I see that it went off. Okay, are we back? Are you with me? I just want to make sure that I'm on record, okay? Hopefully you're here, otherwise I'm in bad shape here. So my computer went right off on me. Once again, I'm learning a lot. This whole thing is timed, I guess. So now let's look at this. Now that you see how to convert, let's do it for all conversions. So I have a lot of problems here. I probably have more than I need, so you will have access to all of these, but I probably am just going to discuss a couple of them. We just did minutes to hours. So I want to get rid of minutes. The 60 minutes is in the denominator. I have 180 over 60, gives me 3 hours. 5 minutes to seconds. I want to get out go the minutes, in come the seconds, 1 minute per 60 seconds. Okay, let's do a fraction. 9/2 gallons. So I want to get rid of gallons. I want to bring in quarts. 4 quarts per 1 gallon. Ounces to pounds. 12 ounces. I want to get rid of ounces, so ounce goes in the denominator. How many ounces in 1 pound? 16. I got 3/4. Are you following? I hope so. If you use this organization, the conversions will be very organized. So you have access to seeing all of this. Looks like I have to change my page number. Hold on. So once again, I had done a large number of conversions, and you have access to seeing all of them. At this time, I'm just going to pull out a few and not discuss every single one of them. So let's look. Let's look at number 20. We want to go from ounces to pounds. So it might look like this, like having that space there. So you want to say out go the ounces, in come the pounds. You're going to have this 96 ounces. How many ounces in 1 pound? 1 pound per 16 ounces. Out go the ounces, in came the pound. 96 over 16. I divided by 4. 24 over 4 gave me 6 pounds. Continuing on, I would have you do these problems. Number 26. Every day of your life, almost, you're converting inches and feet back and forth. So this is a highly used one. We want to get rid of the word inches. We want feet to come in. 12 inches in 1 foot. Out go the inches, in come the feet. 30 over 12, you divide by 6, we get 5 halves, 2.5 feet. 15 quarts equals how many gallons? Is that we want to get rid of quarts. So there are 4 quarts in 1 gallon. The quarts cancel. I have 15 over 4. When I divide 4 into 15, it goes 3, 12, remainder 3, and I have 3 3/4 gallons. And here's another inches to feet. Here's feet to inches. Let's do 38. 24 plus 3 is 27 over 4. I want to get rid of the feet. I want the inches to come in. The feet cancel. 4 goes into 12 3 times. 27 times 3 is 87 inches. So there's a huge number of samples, examples, way more than I would have time for in class. Look at questions 39 through 46. These take 2 or 3 conversions. Maybe I would give you that as an extra credit question on your test. Not sure yet how this will proceed, but that's a possibility. So let's look. On number 40, it says we do not know conversions from tons to ounces. However, we do know tons to pounds, and we know pounds to ounces. So this is conversion 1, and this is conversion 2 here. So let's look. Tons to pounds. I want to get rid of the word ton. I want pound to come in. And then I want to get rid of the word pound, and in comes ounce. So I have 2 times 2,000 times 16. I need to end up with ounces. Do you see? The tons canceled, the pounds canceled, and I have 64,000 ounces. On number 46, we want to go from yards to feet. No, I'm sorry, we want to go from yards to inches. So first, I'm going to go from yards to feet, and then I'm going to go from feet to inches. So let's look. We're going to have 9 plus 1 is 10/3. I want the yards to cancel. In come the feet, but to go from feet to inches, the feet have to cancel, and I go to inches. So now I multiply the 3's canceled, I get 120. Okay, you will see this. You can do that one on your own. And then we will just look at one more. We will look at 62A. We want to go from pounds. Oh, that was a word problem, I believe. As I said, I'll need my book open the next time. So the question was, how many, let's see, it was days, how many total tons? He did 3,500,000 pounds per day, and he did 5 days, so the days cancel. I now have this times this, and I need to get rid of pounds, so there are 2,000 pounds in 1 ton. I multiply the numerator, and I got my total tons. So this will be visible, and also I will be posting the notes, in D2L. As I said, I have to go over that and make sure I'm doing it correctly, so you have access to them. It would be under content, and I'm going to label it as Math 1050. Today is March, St. Patrick's Day, and it will look something like that. So that will be today's notes. I have a couple other scans in there. They will all be under content, and as I said, I need to learn how to make sure I'm doing that correctly so it's visible for everyone. I hope that you were able to follow this, and I look forward to doing more of these, and I look forward to learning a few more things as you do. Thank you very much. This would be your lecture for Monday, the 23rd, but it will be available before then. Thank you, and goodbye.